All right, guys, so this is our third and final day that we're going to spend on simplifying radicals. And today we're going to talk about what is called rationalizing the denominator. Okay, and if you remember, the denominator is the bottom part of a fraction. Okay, so basically what this means, or I guess the rule of thumb is, in math, one of the great unwritten rules of math is you can never have a square root in the denominator or in the bottom part of the fraction. Okay, so you always have to get rid of this square root, or you don't have to get rid of it entirely, you just have to get rid of it from the bottom, and sometimes you have to put it to the top. Okay, so let's look at this example here. Now this one's really easy to overcomplicate. Okay, so it's 1 over the square root of 3 times square root of 16. Okay, we cannot have the square root of 16 in the denominator. Okay, but you should be able to look at the square root of 16 and know what the square root of 16 is. Okay, you should know that that is 4. And if you don't, we can totally break it down. So 2 goes into it 8 times, 2 goes into that 4, 2 goes into that twice, 2 goes into it once, pair of 2's, pair of 2's, pairs come out front, 2 times 2 is 4, okay? So square root of 16 is 4. Hopefully you can see that and recognize that. Okay, so if I simplify this, that's 1 over 3 times, and I can change the square root of 16 to 4. Now, I just get 1 over 3 times 4 is 12, and that is my answer for number 7. So make sure you don't have a perfect square here and you're not doing more work than you need to. All right, now let's do one that we actually have to work and get something out of the denominator, okay? So if you see this number, this is number 1 on your sheet, and it's 2 over the square root of 3. Now, once again, our problem is that there's a square root in the denominator, okay? So we need to think of something that we can multiply both the top and the bottom by, that's going to get the square root out of the denominator, okay? So let's think about this. So if I had the square root of 7 times the square root of 7, isn't that the square root of 7 squared? And aren't the square root and squares inverses, so they would cancel each other out to make 7, okay? Just an example. Or if I had square root of 5 times the square root of 5, this would be the square root of 5 squared. And once again, the squared and the square root would cancel, and I'd just be left with 5. So I'm going to take that same mentality over here. So if I multiplied the square root of 3 by the square root of 3, I would get the square root of 3 squared, which squared and square root cancel each other out, is just 3. Okay, but I can't just multiply the denominator by the square root of 3 because I'd be changing the whole thing. What I can do is I can multiply this over by 1. Right? So I can multiply it by the square root of 3 over the square root of 3. And that's because the square root over the square root of 3 over the square root of 3 is just 1. And when I do that, I get 2 times square root of 3. Okay? And 2 times square root of 3 doesn't simplify. So this here is my final answer. All right, let's look now at number 4 on your sheet. Okay, so once again, this square root in the denominator, that's what I can't have, so I want to get rid of it. So I'm going to multiply this by the square root of 5 over the square root of 5. Okay, and when I do that, my top just becomes 15 square root of 5, and my bottom becomes square root of 5 times square root of 5 is just square root of 5 squared. Okay, now the square root of 5 squared, the square and the square root cancel each other out. So I'm just left with 5 on the bottom, and I have 15 square root of 5 on the top. Now, if I look at this, if I look at what's on the outside of the square root, 15 over 5, doesn't that reduce to 3 over 1, or just 3? Okay, so I'm going to go ahead and change that. This goes to 3, this goes 1. So this is 3 square root of 5 over 1, or just 3 square root of 5. That is my final answer. All right, let's look at number 14 now. Okay, so I see 18 over the square root of 27. And the square root of 27 on the bottom of the fraction is what I can't have. Well, also I noticed the square root of 27 can be simplified. So I'm going to go ahead and do that. So 27, 3 goes into 27, 9 times. 3 goes into 9, 3 times. 3 goes into 3 once, 1, we're done. Circle my pairs. So I'm left with 3 leftovers go in the fridge, square root of 3. So this is the same thing as 18 over 3 square root of 3. Okay, well now, if I look at this, I see my 18 over 3. And 18 over 3 simplifies to 6 over 1. So I'm just going to make this 6 and this 1. So I have 6 over 1 square root of 3, or just 3. Or square root of 3, sorry. Okay, now I still have this square root on bottom that I can't have, but at least it's simplified. Okay, so now I just need to get rid of it. So to get rid of it, multiply square root of 3 over the square root of 3. And so on top I'm left with 6 square root of 3. And the bottom I'm left with square root of 3 times the square root of 3, which is just the square root of 3 squared. Okay, the squared and the square root cancel each other out. So I'm left with 6 square root of 3 over 3. Some of you want to be done, but I'm not quite done. It's like the problem that just doesn't quit. If I look over here, 6 over 3 reduces to 2 over 1. So I'm going to change that to a 2, change that to a 1. So I get 2 square root of 3 over 1, or just 2 square root of 3. All right, let's do one more example, and then you should be good to do the rest. So here I have, this is number 16, by the way. I have 10 over 3 square root of 2. Now, this square root of 2 is causing me problems, okay? The 3 isn't causing me problems. I can have this 3 in the bottom all day long. It's the square root that I can't have. So for now, I'm just going to forget the 3 is there, okay? And I just want to worry about the square root of 2. So to get rid of the square root of 2, I'm going to multiply square root of 2 over the square root of 2. Okay, and when I do that, I get 10 square root of 2 over 3 times square root of 2 times square root of 2 is square root of 2 squared. Okay, and then notice the square and the square root cancel each other out. So I'm left with 10 square root of 2 over 3 times just a 2, because the square root and the squared cancel each other out, which is 10 square root of 2 over 3 times 2 is 6. Okay, now I can simplify this. So, 10 over 6 simplifies to, each of these 2 goes into, so 5 over 3. So this is 5 square root of 2 over 3, and that is my final answer.